Hi everybody, and welcome to this webinar of the Maths 2.0 course in the Teacher Academy. A very warm welcome to those of you who have joined this webinar from all across Europe. We are very happy to have you on board tonight. If you want to use the chat, you can share where you're coming from. We would appreciate a lot. My name is Nair Carrera, and I'm one of the moderators of this course, along with my colleagues Ben, Katerina, Irina, and Anastasia. Before we start, we're gonna ask you to mute your microphones. You're probably muted already, but I think that some of you have not, so please mute your microphones so that we don't hear any background noise, and we will do the same with ours. If you have any question during the webinar, please post them in the chat, and we will relay those questions after the webinar to Tulia. Also, make sure when you write a question that you address the question to all participants so that everybody can see the questions. And we will ask all of these questions and also the questions in the Padlet to Julie at the end of the presentation. Okay, so also for you to know, the presentation is being recorded, so if you have to leave early or anything, don't worry, because you will be able to access the recording afterwards. It will be published soon in section 4.1 of the course, so that you can go there and check the presentation anytime. Most of you probably know already that educational robotics are more and more used in the teaching methods nowadays, and that an increasing number of teachers are using them to develop competencies such as programming, problem solving, or critical thinking. So if you're wondering what is the best approach a teacher should use in order to use robots in their classroom, stay tuned to this webinar as we are about to start. For this purpose, we have here a very good speaker today with us. Her name is Tulia Urshitz. Tulia, I hope the surname is properly pronounced. I'm sure most of you already know her. Tulia is a math, science, and ICT teacher in a junior secondary school in Verona, in Italy, where she uses educational robotics to attract more students to STEM subjects. She collaborates with the School of Robotics of Genoa, where she is a teacher training in the use of ICT in education, and she's a pilot teacher and moderator of teachers' communities of practices within the Ingenious project. Tulia is also involved in several European projects on STEM education and gender, and she's currently part of the GoLab project and a scientist ambassador in Italy. Tulia, you need to tell me where do you take your time from in order to do so many things. So I think she's the right person to guide us through this topic today. I hope the introduction is okay for you, Tulia. If not, feel free to add or correct me on anything. Otherwise, the floor is yours. We cannot hear you.
Yes, now.
Okay, now we can. Great.
Okay, thank you, Nair.
Thank you.
Perfect. Also, my last name was perfectly pronounced.
Okay, thanks.
Okay, there is only Irina who is sending us a message that she's not able to send messages, but we know that she can join us through other channels. We are here again. And as you probably said, a lot of things. I like very much my work. I'm a math and science teacher in Italy in a junior secondary school. But as you said, I'm also a teacher trainer because working with educational robotics and like I'm doing is very nice. And what we are trying to do in Italy is to involve more teachers that we can in using this methodology. Also, our Ministry of Education is now working on spread the use of laboratories to get a lot of competencies for students in more constructivistic way. So I presented myself, but I reclaim the role of the slides are not working. Just one moment. Yes,
they are not. Yeah. Okay.
This is me. This is the drawing of one of my students, and the lady in the middle is me. This represents my work in the vertical curriculum, as I'm a teacher in the junior secondary school, but I am also having some lessons in the primary school, in the kindergarten, in a kind of job shadowing to involve more teachers in this way of working. When I was younger, I was very bad in math, so I took classical studies, but then at university I discovered that it was the way they were teaching to me that was my difficulty. I was very afraid of mistakes. I had bad values, but during my university, I discovered that it is possible to enjoy and to do differently. So we can start with a question, and this is what I want to ask to you. There is an approach, an interactive approach. If you go to menti.com in your browser and use the code that you find here in the slide, you can write down what is the influence that mistakes have in your students' approach to math. Usually, this is a big problem because mistakes are really what stops students to enjoy math lessons, even if it's very nice when they have good results. So please go on menti.com and write down your answer. I will wait for a few minutes to see if you are able to join this. Okay.
We can also use the phone, right?
What?
We can also use the phone to do that.
You can also use the phone, the tablet, everything. You can reach this survey from every device. And you don't need to register. It's enough to go to menti.com and use the code that you find in the upper part of the slide, 275351.
Great,
okay.
Thank you.
Okay, now first words are appearing. If you can write just one or two words, we will find a big cloud, a word salad, with all the ideas from all participants. Very nice. So while we wait for more answers, I wanted to explain you why I'm using robots, and I'm speaking, just to be clear, about educational robotics and not as robotics as a discipline, as a subject. And robots are very useful to engage more students to STEM subjects, and especially to STEM subjects inside the curriculum. This is the way I'm using robotics, but of course there are other ways, like taking part to competition, or having some clubs, or going to Codel Dojo. Everything is very good, but the way that I want to share with you is using robotics inside the curriculum, especially the math curriculum. Indeed, we cannot speak about just one curriculum, because you know that math is something really connected with other subjects, like physics, like science, like technology. Also, is an universal language that sometimes is not very clear to all the participants, all the students, sorry. Also, working with robots allow teachers to work in an inclusive class, and by inclusive I mean engaging all students starting from students with learning difficulties, going to gifted students, and also engaging girls, engaging girls to math. The code, someone is asking for the code. I can write here in the chat. The code is 275351. Okay. Robots are very useful also to match pedagogy with technologies, because sometimes it seems that technology is just something not linked with the real things that we are doing in the class. And also some colleagues object that is real more useful going first through contents and then going to use technology or other kind of other things. I have experience. I'm working with educational robotics since 2008, and I saw very good results. Good results also in many of the national benchmarks that we have here in Italy. I mean, in Valsi tests. This means that working with educational robotics is also a way of developing critical thinking and the computational thinking that are below. Also, working with robots, I mean robotics kits, help to work in a constructivist way. So it means that students can construct their knowledge, grow several competencies, starting from the key competencies, and also going to the discipline contents to know how to solve problems, to find the right algorithm to solve not only math problems, but also every kind of problems. Someone is asking what kind of word I have to submit in Mentimeter. What we are asking is what influence do mistakes have in your students' approach to math? So in one word or a couple of words, just define the way in which you think that mistakes approach the way in which your students approach to math. So,
Julia, sorry to interrupt. I'm going to take the ball for a moment because I need to change something in the panel.
Okay.
I think you can keep on talking in the meantime, right?
Okay. Okay. So I was explaining that I use not robotics like a discipline, but using educational robotics, and robotics kits are just learning mediators, and this means that you can use robots to construct, reconstruct knowledge, to make students learn how to solve a problem, and immediately try to find the solution and check if the solution is good. It's not important which kind of robotic kits you use. In this slide you can see in the middle the Lego Mindstorm EV3, that is one of the most common robotics kits that is used in several classes, not only in Italy but all around Europe. On the right, a Lego WeDo kit, and on the left, a very nice new kit that is a little bit. These are just some examples, but there are several others, and going through all the curriculum. That means starting from the kindergarten, going to the secondary school. Here in this slide, you can see on the left, now robot. We have also now at school, and now is very good for working with autistic children. The only problem is that is a little bit expensive, but there is a competition that is really taking place all around Europe that give a now robot to the secondary school team who wins the Now Robot Challenge. It is a very nice competition in which students build projects working with this humanoid. It can help with mathematics a lot because I will show you later. It can interact with people and also work with very easy programming language. So in the other picture, you can see the use of makey with fruits. This is for the primary school. Another kit that is shown here is Lego WeDo 2.0, the new one. A marvelous one for the kindergarten and also for the youngest students is Cubetto from Primo Toys. That is very new for all around Europe because it just arrived. Or Bebot and Bluebot. And on the right side, on the right corner, you can see some students working with Dash and Dot with the tablet. So mostly, we can say that the robotics kit that we use in the kindergarten, in the primary school, are programmed through tablets because the touch sense is the most used from students. You can see here that even if you cannot find any number, all the things represented here are linked with the mathematics. There are some little students from the first grade working with the Bebot and measuring, making squares, and on the right, students trying to draw some paths and then make the Dash robot going around the class. So I see that a lot of people answered to my question, and I put here in the chat the link to the results and the influence of mistakes in the student's approach to math. Most representative is disappointment, is a failure, is sometimes is written also as a challenge, a big influence. So working with robots, and that was what I wanted to tell you, is very nice because the role of error, of mistakes is completely different because mistakes are the way in which students can just check what they can do better. And it doesn't mean having bad marks, but just check what is working wrong with the robot. This picture is from one of my students while I was explaining something with math. You can see also the calculator on the desk. And this is a very common for many students because they think that they are not able to work with math. Sometimes it's only that they are not able to understand, they just put on earth things and they are not able to understand some concepts. So in working with math, of course, you are all math teachers, is hierarchic in the meaning that if you lose something, you are not able to work with other things that the teacher propose you later. So to avoid this situation, you can engage students from the really beginning. Here you can see the now robot just having a dance with little students. It's not a joke. I was explaining to them about barycenter, and of course you can do also with other kind of robots, but now it's very powerful because it has a lot of grades of freedom, so it can reproduce the physics of the human body, and is really incredible how little children are attracted from all kinds of robots. Of course, they see, in their eyes, robots are linked with games, so they don't see the mathematics behind, but they can understand really well if you use such kind of mediators. In most classes, I don't know if in all around Europe is the same, but in Italy at least, we have some teaching challenges in our classes related with the fact that we have students with different needs. Some of them have a problem with dyslexia, and this means that with math, for instance, is problem with calculating some working with calculus, and also they need to work with some mediators, and the robots are really very good for them. They also don't feel like being different from the other students because they can really complete tasks like all their mates. Also, for students with hyperactivity syndrome, robots are very helpful, and they can stay on a problem, on a task properly. Then also with students with different languages, they usually, it's true that mathematics is a universal language, but if you work with robots, you have a kind of also of a language mediator that helps in giving, in bringing the problem more easy to be understood. Girls are very fond of robots, and is very strange to see that they are not, they have a different kind of approach to robots than boys, in the meaning that maybe they are not used to build. They are very good in programming. They can bring the bug, so solve tasks about mistakes and find what doesn't work in a program, for instance. But they are not very good in the engineering part of working with robots. And then gifted students, of course, can find a way to develop their creativity, work on their ideas, and find also proper solutions to some kind of problems. So, again, the slides that don't work. Let me check what is going wrong. Okay. I think that not all the slides uploaded, so I will work in another way. I will try to share. Nair, can you hear me?
Yes, I can.
Can you confirm me that not all the slides are properly charged?
Which one do you need? The next one?
Yes, can you put the number 9?
No, no, I cannot.
No, okay. So I will try to
Can you
upload. Yes, I will upload the. Okay.
or maybe you can share the screen?
Okay.
I don't
I
know.
hope that no one will have any problem with my desktop. That is like the work I'm doing, very full of things.
I'm
So,
sure they won't mind.
okay, just one moment. Okay. Tell me when you are able to.
We can see it now.
Okay. Okay, in this way, I'm not able to write in the chat for the moment, but I will do it later. Okay. Can you see just one screen or both of
We
them?
see both.
Okay, so you have a stereo vision on that.
I think I'm not able to write in the chat either, right?
No, because,
Found it. Yeah, yeah, I got it here. Great,
okay,
great, thanks.
so I go on from
Yeah,
here. Okay, so why we use educational robotics? We use it to involve students in STEM, as we said, stimulate motivation, develop key competencies, reduce gender gap, share experiences, but most of all, and this is the reason for which we are here, to learn math and to make math fun and really engaging for all the students. Of course, working with robots means also to change the set of our classes. This is an example from the Future Classroom Lab in Brussels. We have to rethink spaces, but of course, we are not all so lucky to have the nice technology that you have there at Yun. We can think anyway to work with desks in ISOs, or to have some places in the class to present, interact, investigate. So to define different corners in the class. One example that with which I want to start is this one. That is the one on the left. The one on the left is the way that usually I present robots to my students. I don't give in advance explanation about the use of the program, or to make the students be aware of all the things related with the problem, but I make them discover it. It's written in Italian, but it's quite easy to understand. Here you have the task was to program a robot that is moving with a constant speed for 1 meter, and they had to write a different program with the different powers of the robot. I didn't tell students how they could make a robot moving for 1 meter. This is something very nice, because usually, I don't know if some colleagues agree with me, circumference is a topic that students in the middle school don't love. I find a lot of difficulties in making them learning rules about and put on earth how to calculate the circumference or the surface of a circle. But if you ask them to move a robot for 1 meter, they arrive to different solutions. What is nice is that the task can be done with a different approaches, considering with the age of the students. So if you are in the primary school, you can just ask students to put a string around the wheel of the robot. They can find the measure, they can find how many times the string stays in the 1 meter. So you can introduce them with the concept of measure. Or if they are older, you can just ask them to calculate the formula of the circumference. Again, if they are in the secondary school, they can they already know something about motions, so they can also work with how can I say, they can go deeper in the task. Sometimes students, when working with robots, also ask to bring their own robots, and we work. So what is important is not which kit we are using, but what we wanted to which is the task, what we wanted to do. In this case, you can see different robots. All the things that you will see here are related with measuring. On the right side, here you can see better. I was working with some students in the 8th grade, and the robot that you see is a blue bot. The blue bot is a robot that usually is used in the kindergarten or in the primary school, because it's very easy, and you can program it just pressing the over the back of this little bot. I call it a pina, that means little bee, because the first kit was similar to a bee. And I asked the students to find the circumference of these wheels. You see, they cannot go to a direct measure because the wheels are hidden under the back. So they had to find an indirect way of measuring the circumference, and they used the rule. So they were divided in groups, and some of them just put the rule and put a sign with a choke on the wheel, and they could measure after moving the robot. But some others went to different solutions, like measuring how many bots they found through the movement. So they made a mistake. I didn't tell them anything wrong, because some mates discovered that the approach was not the best one, and they could debate and argue why one way of finding the solution was better than the other. In this way, you can also explain to students that each mathematical problem can have different approaches and different way of finding a solution, and they start being used to find their own solution, and not just answering with the things that a teacher can expect, or they think the teacher can expect. They don't put on earth, but they can think critically about the solution. Here you can see that students not in the desks many times. I can say almost always. And of course, if you want to work with educational robotics, you also need to move from the desk to the ground to rethink spaces and also to rethink the way in which the teacher works in the class. But if you look at here, do you remember the students that I showed you in a previous slide that was sleeping on the desk? He is very active and he is working with mates and also he is enjoying about that. The work they were doing here was it was not a simple task. I asked them to move the robot with different powers and to check what was the speed. This is a sheet for young students, so I didn't explain and I didn't ask them to calculate the speed, but just to tell if it was slow, very slow, normal, fast, and then to measure the distance. We spoke about also friction. So we introduced some physics knowledge, also working in a different topic, and then they could find the distance just working with a watch. The same task, I used the same task also with other students from the 8th grade. And to them, I asked to calculate the velocity. You can also work with it in the 7th grade when you speak about ratios and work with the velocity like the quotient between the space and the time. What is very interesting to see is that if I just ask them, working with the textbook, to find the velocity, they don't think about how they can move from the measure in meters by seconds and kilometers by hours. But working with robots, they can check if their prevision was really properly. What is very good is, when you work with robots is join the real world tasks like this one. Of course, for teachers from the secondary school, the high school, this task was presented to younger students, so it's not perfect as okay. We don't usually speak about derivatives in the middle school, but the task was to find what is acceleration. And acceleration is a concept that through robots you can also see and not just calculate, because you need to find the way of moving the robot with different velocities. And for doing that, you need to program different blocks with an increase in speed. It's really very powerful. And if you wanted to move more on real world task, you can ask to make the robot climbing. And so the difficulty is increasing, and they have to find which is the best way to make the robot climbing a slope. So the solution can be really creative sometimes, like here. You can see they discovered that if you increase the mass on the robot, you can make it climbing. And some students can also compare with, for instance, their dad's way of doing when they find the snow on a slope and the car is not able to climb a slope, and you can just turn backside down the car, or just put some weights on the power wheels of the car. And then, after they discover how to make the robot climbing, you can formalize, and you can speak about the relation, and about the link between the force and the acceleration and the mass, of course. What makes robots be able to be used all over the curriculum, the vertical curriculum, is that you can find a proper robot for each cycle, for the kindergarten, from the primary school, and also for the secondary school. This activity, this programming language is Blockly, and this is part of the code.org academy that I think most of you know. And it's similar to Scratch programming, but it's from Google. And it's available for free from everywhere, also not at school. But if you use it at school, you can go more deeply on math problems. Similar to the previous one that I showed you, is this one is Blockly for Dash and Dot. So if you worked just with the software, you can make more powerful trying with the robot, which is the effect of a program. And the students can also create different programs to find what does it happen if you change just one variable. And if you see on the left side of the screen, you can work also with variables, with the controls, with loops, also starting from the very young students. I mean, from the second grade, as soon as they are able to read. If they are not able to read, but they are able they are already used to work with tablets or with the technology, you can use Lego with you. And this is a program from Lego that is very easy because it is just an iconic language. You see that those programs that I showed you till now are just visual blocks programs, and they can fit very easily in the class. This because most of the teachers are not engineers, are not programmers. I didn't tell you that my degree is in forestry sciences. So I finished university and I saw the computer for the first time when I had to do my thesis. But I learned with my students many things, and now I'm able to use simple programs. It's not difficult, it's quite easy. What is really important is to have in mind what is the target that you want to reach with a problem. This one is the software for the Lego Mindstorm EV3, and with this one you can start from I can say from the third, fourth grade. I mean in the primary school, if the students are already used with robots, at least with simpler programs. And you can go on using also, I can say at university. because you can add also the work with data logging, and so you can work with students working with sensor, working making provisions. It's like having a kind of laboratory with your students. What is nice is working with robots. Is mostly in the first cycle. I mean, from the kindergarten to the middle school, to the 8th grade, because usually we don't have laboratories at school. At least in Italy, is not common. And if you if you have robots, you can not move the class to the laboratory, but move the laboratory in the class. It's like using, you can add also other kind of tools, like, for instance, virtual laboratory, remote laboratory, like a Go Lab, just to mention one. And if you join the use of robots with such kind of tools, you really can cover not only the discipline tasks, but you can grow several competencies. Also, and maybe it's not the last one, but one of the first, working in team. That is something that for the future will be really very requested. Working with math can also be challenging if you ask students to design a game. You see here we were working with in the Cartesian axis, but not it was not boring, but it was challenging, because when you have to prepare such kind of game, you need to think how to design, how to program, and which is the task that you want to reach with such kind of game. You see, for instance, you can start with a very simple task. Here you can see there is a tablet and some calculation on the right. This is a task that I gave to my students in the 6th grade. And you know, usually you don't work with ratios in the 6th grade. At least in Italy, you start in the 7th grade. But if you want to calculate how many seconds the time that the robot needs to be programmed, you need also to introduce more difficult tasks. So it's not just working with one concept after the others, but you are constructing a lot of tasks. Someone is writing about the kindergarten. I will also show you some example from the kindergarten. Here is now robot. You can see on the back that also now, even if this robot is so nice, so perfect, it can be programmed with a really easy software, that is Choreograph in this case, but it can be also programmed with Python. So for teachers in the secondary school, it's very useful to go deeper with yes, someone is telling that it is expensive. That's true. And our schools, I work in a public school, so I started with just one robot, and I had one robot for the whole class. Then through projects, competitions, prizes, I improved the numbers of robots in the school. And also we are thinking of sharing robots in a network of schools. So if I just buy one kit and another school buys another kit, if we program the user, we can share them. So just think on the value. I think that it's possible to find funding to buy robots in several ways. In Italy, at least now, there are several proposals. There are several. How can I say? Yes, the Minister of Education gives some calls for funds, and the schools have to project how they would use technology in their classes. Doesn't matter. I showed with the iPad, but most of the technology I showed you are open source. Of course, not those software linked with the Lego robots, but you can use them also with some of them with Scratch, or some others with if you are in the secondary school with C++ or with Java, and you can use not only with with iPads or with tablets. Some of you is writing that is just fiction. I can tell you that we are very poor. I started working with robots because of one of my special needs students. We went to a workshop in a museum, and I discovered my student waking up and being very interested. So I asked to my principal, and we found step by step in a few years the way of growing funds. So it's not about funds. Just think behind. If you are really motivated, you can find a way of working with them. At least also in the East countries, I see that some of the teachers come from Romania, from Albania. There are a lot of European projects that give funds for working with such kind of technology. Here you can see the cubetto is Primo Toys, that is really very, very powerful in the kindergarten. Can you imagine if you can start working with the variables starting from I can say 5 years old students. When they grow up, they are really able to solve a lot of problems. Sorry, Irina. I just see for a few seconds that you're writing in the chat, but if I share the screen, I'm not able to show everything. I see that the time is.
Yeah, thank you, Irina. It's a question from the participants. We will wait for you to end the presentation, and then we come back to the questions.
Okay, I just go really fast through I just discovered that it's very late. I go quick through the slides to show you that maybe if you saw my TED presentation, linking with the real task problem is one of the best things. And it's just about creativity and listening to your students. You can find many other ideas. Now I stop sharing my desktop, and I'm here for questions. Okay.
Okay. Thank you very much, Tulia. Can you hear me now?
Yeah, I can hear.
Okay.
Sorry,
great.
I was speaking and speaking and speaking.
Right on time. No worries. I'm sure teachers won't mind. You have given us like a lot of ideas and resources, so it's great. Thank you very much. Let's just go quickly through a couple of questions we got in the chat. So Irina took a question from the chat. We've got a few also from the Padlet, so we just try to go through them. Now the chat is moving so fast. Okay, so question from the chat. So do you use educational robotics for the full mathematics curriculum or only for the specific topics?
No, I use it for the full curriculum. Of course, there is not a syllabus on how to use educational robotics, so it's about the experience and the sharing of best practices with other colleagues that you find how to fit educational robotics in all the steps of the vertical curriculum. In my school, we are working in the vertical curriculum from the kindergarten to the secondary school, and we found some topics, some core contents to be used in all the classes with educational robotics.
Okay, there was also a question in the chat asking if you could share the presentation, the 46 slides.
Yeah, sure.
Okay, so
sure.
Julia will kindly share the presentation.
Also, Antonio, I see that he's asking about a playground. This is just something related with the use of the iPad. A new app is a playground it's on the Apple Store. It's very powerful, working, for instance, with Dash and Dot, because you can program the robot also with the young students with a more complete programming language like Java. And it's open source. You just need to have the robot.
Okay, great. Thank you for that. Another question: where do you find the relevant teaching resources?
Okay, I think that this is a really important question because teachers who work with educational robotics need to share with others what they are doing, because at least at the beginning, other teachers are afraid of being not adequate in the class, and they need some resources to find helpful. I can tell you that you can go on Scientix website. You can find a lot of open source resources related with robotics. There is the Roberta project, or there are several others like the iTech project, or I can share a list of projects that are in the Scientix website that can give us some ideas.
Yeah, I was going to mention that since we're a bit running out of time, all the questions that maybe we cannot answer now, maybe you can address those in Padlet and also share maybe the list of resources if you want.
Yeah.
It would be helpful for the participants.
Yes, for sure. I will share the presentation, of course, and
Great.
yeah, and also the resources. Maybe if there are special questions, I can share in the Padlet some answers, or in some other places that you find useful.
Okay, let's try to answer a couple of questions more. So Jasna is asking, what is the average price of educational robots? Because
it depends. You can find cheap robots, really cheap robots. Working in the high school, working with Arduino is very cheap, but it doesn't fit very well in the primary schools. I mentioned a little bit at the beginning. But I don't want to give a publicity to any robotic kits. I can say that at least in the high school, it's easier to find the cheaper robots. In the primary and in the kindergarten or in the middle school, you need to go more with the concept with robots that can fit for all the teachers.
Okay.
Also without programming, bigger programming abilities, coding abilities.
Okay. There was another interesting question in the Padlet that came from Francesca from Italy. I don't know if she's here. She was mentioning that in their school they receive an EB3, but they only have this EB3. You saw it.
I read about that. I also had a webinar for the India, that is our national counterpart for scientists, at least. I worked for 2 years with one EV3. Of course, it's not the best solution because in the constructivist approach, you need one robot for each 2 or 3 students. You can arrive at 4 students. But if you have just one is better than nothing. So you can start with one, and then join another one, and then add some more. Yeah, you can.
Definitely.
You can also be very good with creative robotics. So you add the creativity. Just building a robot with some paper and putting and working with Make or with little bits, giving an earth and programming it with Scratch. So you can start really with the Scratch. It's just what I suggest is to stay in some community of practices of teachers, in some MOOCs where you can share in some community, and you can share the best practices. Sharing is the basic about resources and also about teachers.
Sure, thank you. And there was another question from Adriana. Do we teachers need any training about these educational methods?
Oh, yes, of course. uh, I think that I'm also teacher trainer for the Piano Scuola Digitale in Italy. In Italy, we are running a lot of training courses now, but of course, new technologies are changing very quickly. And if you want to find ideas, you need also to be, I can say, to know how to use robots. You don't need special abilities, but at least you need how to use blocks. You can also ask help from some students, because you don't have to be afraid. The students are very eager to help a teacher if they work in this way.
Yes, sometimes they know more than us, actually.
What I forgot to mention is about assessment, about evaluation. Working in this way, you need to have some rubric, to have some observation. You can measure the learning through other kind of assess, but when they work with robots, you can ask also some parallel projects or documenting what they are doing, because this is something that a lot of people ask, how to assess.
Okay, there was another question coming from Luca. If you have any ideas about interdisciplinary experience with robotics that involves language, history, or other disciplines?
Yes, with language, a lot. I also had a very nice experience. I also wrote a paper on it I can share with you. We had an experience with the 50 girls in Italy working with others in Brussels for a project. They had to program some robots, a common task, working with interactive whiteboard. The Italian girls were working with French-speaking girls, and the common language was English. So, of course, and also robots speak English. You can also make them speak in other languages, but you know, when you build with Lego, you don't need to have a language task. But you can also speak about the philosophy. You can also speak about other things, because there is also an ethic in robots, and we can teach students that we can use robots not only as weapons. They are used of that, but to help people, and also what is really important to understand is that through robotics you can prepare students for future tasks, also with other kind of technologies, because they learn how to think and how to solve problems in a like thinking out of the box, because sometimes you need to find different solutions.
Okay, thank you. There is Pablo just share resource. So thank you for that, Pablo, to start
Thank you.
using robotics. You have already mentioned different questions and ideas and stuff, but there was a question in the Padlet asking if you could give them some tips to start with, like in
Yes.
primary education.
Yeah. There is one resource that I can share with you. In one of the last slides, you can see that I showed working with the Scratch Junior. There is a resource that I put on Scientix website. I mentioned that it's possible to start to work with mathematics, starting with code. First, you start coding, and then you learn mathematics. I also with unplugged activities, and for instance, you take some circles of different colors, make children move on this circle with a task, reach, I can say a toy, and they have to find the best way, the shortest one. Each time they go on the green, they gain 1 point, and if they go on the red, they lose 1 point. So you can also speak about if you do something, then something happens, else something more. And you can speak about programming, mathematics, because they start counting, about paths, about choices, about precision, about mistakes, and this is in the kindergarten. And then it's just about what is really important is to think which is the target in meaning of learning that you want to reach. Then work with someone else who has a little experience with robots and just try with the little things that are already done. Then you can improve step by step.
Okay, there was another question. I'm not sure I understand. Maybe you do. So you use robotics for grasping a basic concept, and then they practice in a common way. Does that make sense? So it says.
Yeah, sure.
Okay.
I don't use only robots. I use a lot of paper, scissors, a lot of exercises, also, I can say traditional ways. Usually, I have 2 hours out of 6 of my lessons with robots, and this is like grasping with the problem, find a solution, and then we formalize. Of course, you need mathematics, needs also exercise, and through robots you have the discover, and then you have to formalize.
Okay, great. And then we go for the last question. So what do you think about drone robot? Is it also for coordination of movements?
Okay, drones, students love very much drones. I think that, of course, they move in the space, and you can speak about a lot of things. It's good for coordination because you need to pilot them is good. I think that I prefer little robots because you can do many things. Of course, drones just fly, and other kind of robots. Usually we see like rovers, but we can make them becoming all kinds of things that we need to present. So I wouldn't buy drones, also because they remind me other kind of uses of robots, and I prefer, for instance, prosthetic robots. And you can speak about the grade of freedom and how to solve some problems to join that.
Okay, thank you. There was, it is not a question, but Maria from Spain shared a link to a twin space,
Yeah?
because they built a project in Spain dealing with Scratch. It's in Spanish. I checked it before, but in case somebody wants to have a look, I'll share the link in the chat so we have it there.
I think that Scratch is a very good example of a coding activity that has a lot of concepts about sharing, about remixing. So usually you don't allow students to copy, but in this case you need to copy if you find the best solution. Also you can find ideas. And Scratch is growing, has a lot of experience and is growing a lot of activities and communities. You know, you can use a Scratch to program a lot of robots, like Lego We Do or like Make Make. So Scratch is basically very good. And also eTwinning is a good way to share with other colleagues. I would suggest eTwinning, Scientix, and all open educational resources. There are tons of resources. Usually Italy, Spain, England, a lot of the UK, and also Austria, Germany are very good in disseminating. Many other countries are working with educational robotics and with robots in general, but maybe they don't yet have the way of sharing. ETwinning is very good, and also science.
Great, thank you. Thank you, Tula, for these answers. I think we could end it up here because it's 15 past 7 already. So thank you very much for this very inspiring presentation, Julia. I'm sure it's going to be really useful for the teachers. What do you say, teachers? Have you enjoyed the presentation? Let's see if somebody can answer, hopefully.
Maybe I spoke too much and I left just a little place for questions.
No, no worries. I'm sure they will use all the materials. We will share the presentation so they can also have a look at that. And then
I can also write my email here.
great, thank you, so that they can write you.
Yes, also through other channels like in the chat, but or in the academy.
Okay. Yeah.
Yes, Irina is thanking me, but I want to thank Irina because I think that this course is so nice, so beautiful, and so inspiring because because of all of you. But Irina is really the earth of everything.
Definitely. So thank you from me as well, Irina. Thank you, Tulia, also for this great presentation. I hope it has been useful for the teachers, and that if they are a bit afraid of using educational robotics, they can start to use them now. And thank you all the participants who have joined this webinar tonight. I wish it was useful for you. Stay tuned to the social media channels. Irina will be on Facebook, also Twitter, with hashtag #MathToMOOC. And I think that's it. Thank you, everybody.
I will answer,
yes?
I will answer the same in Facebook on the MOOC course to all the questions that
Perfect.
they will
So they can still go there and ask anything they want. Okay, great. Thank you very much, everybody, and have a nice evening. Thank you, Julia.
Thank you, Nadia. Thank you,
Thank
everybody.
You.
Bye-bye.
Bye. Nice evening. Bye.
Bye-bye.